right, well, good morning. It's great to have you here. Thank you for being here. Thank you for being at reInvent. Hopefully you're enjoying it. It's Wednesday. Hopefully you're not running out of energy like I am, and you're still good to go for a few more days. But we're really excited to have you here with us. My name is Jeff Bartley. I'm a product manager on the AWS DataSync team, and I'm joined by Adam, who's here from Resilience, and is going to share with us their experience using DataSync to scale out their biomanufacturing industry capabilities. So super excited to have Adam with us. He's got a great story to share. So from an agenda perspective, we're going to start with an overview of DataSync service, and then we'll deep dive into it. What are some of the capabilities, use cases, things like that. I'll then turn the time over to Adam, and he'll talk about Resilience and their story of using DataSync and their CDMO capabilities. I'll then talk about some new DataSync features that we launched over the past year, and then give a demo of one of our biggest features that we launched this past October. It's called Enhanced Mode, and then I'll just do a quick wrap up. So if you've ever tried to move a lot of data at scale, we're talking about terabytes of data or petabytes of data, millions or even billions of files, you've likely experienced the challenges that are around that. As I've gone out and talked to customers who have tried to do this on their own, these are just some of the challenges they hit. You know, they typically start with a do-it-yourself approach where they're building their own scripts, maybe combined with other solutions, commercial solutions or open source solutions. There's a lot of overhead there. Security, of course, when you're moving that much data is super critical. So they run into challenges of, hey, how do I secure my data in flight and at rest? How do I deal with that properly and do it in the right way so that it doesn't lead to problems down the road? Also, how do I verify my data? It's one thing when you're copying like 10 or 12 files and you can just look at it and go, yep, they're all there, everything's good. When you're copying millions or billions of files, like you can't do it manually. So you got to automate it, and how do you do it in a way that's going to be efficient? Errors are going to happen as you go through a large-scale data transfer like this. So, things in the network, things in the storage, things in software, how do you recover from those gracefully and keep moving? Often, these large data transfers are happening on a schedule. Timelines need to be met. How do you do it in an efficient way? How do you deal with network availability issues? Connections go up, connections go down. When a connection goes down, does everything just fall over and die? Hopefully not. And then how do you assure performance? How do you achieve those performance goals you're looking at? So just a number of challenges as I've gone out and talked to customers that they've had in the past. And so AWS DataSync was built to help our customers address these challenges. It's designed to help customers move their data quickly, securely, and reliably. It's built on a custom network protocol that maximizes available bandwidth through parallel throughput operations, and it automatically recovers from some of those network issues that I was talking about so that we can continue moving even in the face of lossy networks or challenges with connections temporarily going up and down. DataSync encrypts all data in flight using TLS 1.3, and then we support encryption at rest on the storage wherever possible. It's a fully managed service, and so we take care of a lot of the heavy lifting that's typically associated with large-scale data transfers, things like data validation, logging, detailed reports, and automatically connecting to your storage services. And then DataSync is designed to be easy to use, so we have built-in capabilities like scheduling, filtering, more and more reporting, tools that we're building over time, lots of things to help you with your data transfers at scale. So as I go out and I talk to customers, repeatedly we find them using DataSync in these 4 use cases. So the first of these is the need to move their data quickly in response to business workflows. And so a common use case that I give, and Adam's going to speak more to this, is in like the life sciences industry where customers will have instruments on premises. Think of like a genome sequencer or something like that that's outputting a lot of data. Analyzing those results, processing them quickly is super important to the business. And so they need to move that data often into the cloud so that they can analyze and process that data. So DataSync is there to help them move that data quickly as it's being generated by those instruments. Data migrations are a key use case for DataSync. So a lot of customers, whether they're evacuating a data center, or maybe they're shutting down a storage system, or they just need to move data into AWS, DataSync has a lot of capabilities that help them with migrations. Other customers are using DataSync to protect data. So they want to make a second copy of their data, often in the cloud. So they'll set up DataSync on a schedule and then just run it and just make a second copy of that data. Maybe it's for business continuity or DR purposes. And then finally, a lot of the data that's on premises is cold when we're talking about files and objects, especially. You can think of those PowerPoints or those Excel files that you created 5 years ago, you've never touched, but it's just sitting there. But you don't want to get rid of it because, hey, one day you may need that Excel spreadsheet, right? But a lot of that data is cold, and customers are like, well, I don't want this sitting on my tier 1 storage. I want to get it off. Maybe I want to move it into something like S3 Glacier or Glacier Deep Archive. Take advantage of the cost and durability capabilities that S3 provides. So again, DataSync is there to help them with those archive capabilities. And then, of course, right, it wouldn't be a presentation with a bit of AI ML in there. DataSync is also helping our customers more and more who have AI ML workloads, because DataSync can copy data to both S3 and FSx for Lustre, which are key data storage capabilities that allow for high scalability, high throughput. And so we're finding more and more customers who are using DataSync to efficiently move their data into these storage and then use that data from there in the cloud as part of their AI ML workload. So a new use case that we're finding more and more customers using DataSync for. So let's go into a deep dive of how our customers are using DataSync and what you can do with it. So really, there's kind of 3 areas that DataSync can copy from. One of the advantages that we provide to customers is our ability to copy data from a wide variety of locations. So the first of these is on-premises data, and we support things like file servers, object storage systems that speak common protocols like NFS, SMB, S3. We also support copying data to and from Hadoop clusters. And all of this data can be copied to S3, EFS, or any FSx file system type. So the point here being that we move files and objects, and you can move data between any of these to any of these other storage systems in AWS. And one of the key advantages that we also provide is the ability to copy both data and metadata. It's really important to us to be able to preserve metadata, things like Windows ACLs, timestamps, permissions, particularly important for migrations, moving data from on-prem into the cloud. We also recently added support for moving data to and from other clouds. So we support Google Cloud Storage, Azure, long list of clouds there. Pretty much if you have data stored in another cloud and that cloud offers S3 compatible object storage, there's a pretty good chance that DataSync can just work with it. And one of the key things to point out here is it's not just moving data from other clouds into AWS. You can just as easily move data from AWS into other clouds. We support moving data in both directions. In all cases, we always use secure protocols for communicating with other clouds, so you can be sure that your data is being encrypted in flight as it's being transferred. And then finally, we have a large number of customers just simply using DataSync to move data between storage services within AWS. They may have workflows that require moving data between these services. They may be migrating from, let's say, one region to another. There are a wide variety of use cases. In all of these cases, data is being transferred over the AWS backbone. It never leaves AWS. There's no infrastructure to deploy. But in all cases, we always are encrypting data as we transfer it. And the cool thing about this is that we also take care of translating. So when you're going from like an object store to a file system or back, we take care of doing the metadata translation and things like that. So it's a nice, clean movement of data between any combination of these. So diving a little bit deeper, so when you're doing on-premises transfers, one of the key components that you need to deploy is a DataSync agent. And an agent is deployed typically in your environment. You can also deploy it as an EC2 instance. But it's something that you typically deploy close to your on-premises storage. And we'll talk here in a little bit why that's needed. So an agent is used for communicating with storage that's outside of AWS. You can deploy it as a virtual machine. We support VMware, Hyper-V or KVM, and as I mentioned, you can also deploy it as an EC2 instance. The nice thing is that it's a fully supported appliance by DataSync. We take care of all of the software updates, the patching, all of that stuff. There's nothing that you have to do. That's all automatically handled by the DataSync service. And then when you use an agent, the way you use an agent is you activate it, you deploy it, and then you activate it against an account and region where your storage is located in AWS. So we offer 3 ways to connect agents to the DataSync service running in AWS. The first of these are public endpoints and FIPS endpoints. They are available over the internet. FIPS is there primarily if you work with, let's say, like public sector customers in the US or something like that, and you need that extra level of compliance. We support that. We also support VPC endpoints, and these are available for customers who need private connectivity. They don't want to use DataSync over the internet for one reason or the other. So they can create a VPC endpoint in their VPC within AWS, and then they can use something like a direct connect or VPN connection to connect the agent up into the AWS VPC. All traffic remains within that private network. It doesn't go out to the internet or anything else like that. So again, though, regardless of which endpoint you use, all traffic is encrypted in flight, TLS 1.3. You also utilize an agent when you're talking to other clouds, and there's 2 configurations. So the first of these is you can deploy the agent as an EC2 instance in AWS. You can also deploy the agent in the other cloud. Now, this takes a little bit of extra work. We don't provide native formats for the agent that just work in, say, Google or Azure or something like that, but we do have blogs and documentation that can walk you through that. One of the advantages for deploying the agent in the other cloud is that that connection between the agent and the DataSync service that you see there, data can be compressed in flight. So we'll have customers who have highly compressible data sets. They want to move that data from another cloud into AWS. By compressing that data before it leaves that cloud, we can sometimes reduce their egress charges, reducing the actual physical data that's being copied out of the cloud. So that's one potential way to reduce egress charges when using DataSync. So DataSync, obviously, it's an online network-based data transfer service. So understanding the network is pretty key. So there are 3 legs to the data transfer network path. So the first of these is between the on-prem storage and the agent, then the path between the agent and the DataSync service, and then the path from the DataSync service to the AWS service. And kind of the key thing just to note here is that the agent is not talking directly to the to the AWS services. The agent does not talk directly to S3, does not talk directly to EFS or FSX. And the reason for that is because that path between the agent and the AWS region might be very long. It's typically over a wide area network, and you're going to have things like the network issues that we talked about. The protocols that we would need to use to speak to those other services, they're not always going to be conducive to those long paths. So DataSync, that custom protocol that we wrote is really designed for that long distance path between the agent and the managed service, giving customers that advantage of high speed, even over lossy networks or challenging networks. So that's why that exists. So let's dive deeper into each one of these. So a couple things to understand and think about when you're using an agent with your on-prem storage. So again, we use common protocols to communicate with your storage. The agent uses a multi-threaded architecture to scale our storage transfers, and one of the results of that is it can put some stress on storage systems. So sometimes I have customers who deploy an agent, and it's against these these really old NetApp systems, and they're using SATA disks that haven't been touched for 10 years, and the thing just is not handling DataSync well. And so you just want to be aware when you're using DataSync. We can do things to throttle that down, but you just want to be aware that it can impact your storage, and so you just want to, if you've got slow storage or you've got disk problems or things like that, that can potentially impact DataSync performance. One of the reasons you want to put the agent close to your storage, though, is that it minimizes the latency. Protocols like NFS and SMB tend to be latency sensitive. And then wherever possible, DataSync will use, we provide options for encrypting communications with the underlying storage. And then that path between the agent and the managed service, I kind of talked about this already. Again, we support over the internet, direct connect or VPN. We also provide throttling so that you can control how much bandwidth DataSync consumes on that network link. Typically, especially if it's like a direct connect or something like that, it's got a fixed amount of bandwidth. You want to be, maybe you want to make sure that DataSync's not consuming all of it. You're sharing it with your other applications that are running. We compress the data in flight, and again, all traffic is encrypted. And then finally, there's that last leg between the DataSync service and the AWS storage. We take care of this connectivity automatically. You just tell us when you're setting up DataSync how to configure the access to your storage, and then we take care of everything from there. But again, issues like slow storage can still apply here because some of these services, you can configure the underlying storage in different ways. Things like Amazon FSx for Windows or some of the other services you can configure whether you're using HDD or SSD, for example. So you just want to be aware of how that can potentially impact your data transfers. And again, as I mentioned, all traffic stays within the AWS network for that region. So setting up and using DataSync is really a 1, 2, 3 process. So you start by deploying the agents that we've talked about. You deploy it either on-prem in your hypervisor environment or in EC2 if that works for you, and then or even in other clouds. And then you create locations. And so locations are a resource type with the DataSync service. They define how to connect to your storage, whether that's on-premises on other clouds or in AWS. Things like IP addresses, which protocol version to use, authentication information, things like that. And then you create tasks, and you execute that task to actually do the movement of data from the source location to the destination location. So speaking about tasks and diving a little bit deeper on there, so a task is composed of basically 3 things. It's a source location, a destination location, and then options for how the task operates. These are things like how is data verified, how do we actually move the data, options around scheduling, reporting, things like that. And a couple things to know about DataSync tasks. An agent can run one task at a time. You can run more than one task, but they'll get queued up. And then when the agent has finished the one task, it'll take the next one on the queue. A task always copies data from one source to one destination, and you can configure tasks to run on a schedule, hourly, daily, weekly. We also support custom cron strings that you can put in there. Now, sometimes customers have a lot of network bandwidth, more than actually a single DataSync task can consume at one time. I've worked with customers who have 40 gig or even 100 gigabit direct connect lines from their on-prem storage up into AWS. And they want to maximize that bandwidth. They're doing a large migration or something like that. So one of the patterns that we often employ with these customers is to deploy multiple agents and then to create a task per agent and to partition their source data set, maybe by folder or a set of folders. You can use filtering. We offer a number of different ways to do that partitioning, and then run those tasks in parallel. So using this pattern, we've had customers who have moved up to 1 petabyte a day using DataSync. So a significant amount of data movement using DataSync. So we can scale a lot using this methodology. We also have some customers who have data sets with lots of small files. And in that case, we have another option for scaling as well. So you can also define a task with multiple agents. So if you remember, I talked about how an agent uses a multi-threaded architecture. Basically, by doing this, what you're doing is you're just increasing the number of threads that DataSync can use in a task. And so if you've got lots and lots of small files, this will increase the number of files that you can copy at one time. So this is helpful, again, for customers with lots of these small file type workloads. And so with that, let me turn time over to Adam. He's going to talk about resilience and their journey, what they do, and how they've used DataSync. And then I'll come back on and talk a little bit more about our features and things like that.
So hello, everyone. I'm Adam Mendez. I am head of cloud and data engineering at Resilience. And we're very happy to be here today to talk about this data management platform we've built using a combination of AWS native services, but namely DataSync as the primary mechanism for getting our on-prem data to the cloud. Now, to set the context on who we are as a company and really the motivation for building this data management platform, Resilience is a biomanufacturing company based in San Diego that focuses on providing the rapid stand-up of process design and manufacturing capabilities using something called the Foundry model to essentially help enable other biopharmas, our customers, achieve their goals of bringing their therapeutics to market. And Foundry model is something that I personally believe has only been successfully demonstrated once in one other industry, being semiconductor. But in principle, it's based on building this integrated network with these highly efficient tech transfer processes that allow parts of the business to build towards these incredibly technically complex goals, but doing so starting with the design plans that clients create. So to stick some names to it and provide some examples you might recognize, albeit in different industry, TSMC is the name of one of the most successful semiconductor companies, and their clients are the tech giants, even before they got giant. So think places like Apple, Qualcomm, NVIDIA, essentially all these companies that leverage microprocessors in their products, but who do not actually manufacture their own chips in-house. So instead, the way this model works is that the clients come up with the design specifications for the hardware they want, and they then partner with TSMC and hand over those designs so that TSMC can figure out how to build it on a pilot plant, how to scale it to manufacturing, and then how to actually produce it for the products that the clients then bring to market. And obvious question that is why, right? Why would these enormously successful companies include a third party for all these steps? Apple's not exactly short on money. It's basically two reasons. One is faster R&D. Essentially, without having to deal with the tech transfer process yourself, it frees up incredible amounts of time and resourcing to just focus on the design. And two, it allows for companies to have what's called an asset-light model, which basically means that you don't have to own a manufacturing plant just to get off the ground with a good idea. So this is really empowering for larger companies that want to focus on their differentiating IP, while also enabling for smaller to medium-sized companies that have a great idea, but maybe don't quite have the bankroll to get it off the ground. Now, back to Resilience, the concept is the same, because Resilience really is the first biomanufacturing foundry model company that focuses on providing pharmaceutical manufacturing capabilities centered around 5 areas. That's this biologics, vaccines, nucleic acid, gene therapy, cell therapy, such that our customers can focus on their drug discovery pipelines, while Resilience will handle the pilot scale, the QC and analytical development, and the actual GMP manufacturing services, leveraging their drug designs so that they can bring their therapeutics to market. But being able to do so without this enormous upfront investment in these manufacturing capabilities. Now, to make all that possible requires obviously not only incredibly talented research teams, but also modern data capabilities to facilitate them internally. And that is what we're here to talk about, because you see Resilience has existed for about 4 years, and in that time we've grown to 11 sites, about 2,000 people, million square foot in facility space, and labs that house over 300 instruments. And while those are numbers that we're proud to be able to state, what they really introduce is a high degree of complexity in our digital landscape. And I will call your attention to that last number there, those 300 lab devices, because that is 300 physical instruments sitting in the lab, bioreactors, flow cytometers, digital PCRs, that are all generating this really critical client research data that needs to be analyzed for the purpose of our client projects. And truth is, data management is an area that virtually every biotech company has struggled with in the past. Fact of the matter is that manual data movement is still a way of life at a lot of biotechs. And I could tell you some horror stories as far as what we've seen for manual data movement. It's a lot of hard drives, a lot of box, a lot of teams. Worst case, I have quite literally seen a scientist take out their phone and take a picture of the screen before going back to their desk and transcribing results, still sometimes to paper notebooks. So it's this very broken chain of custody for moving data around. And this model just doesn't work in any sort of scalable way, because what it causes is a complete lack of version control in these potentially proprietary findings. And on top of that, with this working model, there's no way for teams to share data with one another. And we very often see that problem extend beyond just the lab teams to the point that it hinders software groups as well, since they can't properly develop their informatics pipelines around these unreliable, disparate data sharing tools. And I don't bring this up to cast a shadow on the mode that teams are operating in. It's really just to highlight that this antiquated way of working is way of life at most biotechs. And that's just due to a lack of tooling that's really been provided to enable teams to do their best work. So this is where we started. Really our first goal as part of building this data management platform was essentially to solve the operational headaches of data movement to beat this convention. Now, with this, there were a lot of requirements we were holding ourselves to because we knew that we needed to tailor the solution to fit the needs of both research scientists and our engineering teams. So on the research side, we knew that what we built needed to serve as the centralized control plane for data access with all of this key lab data uploaded automatically to eliminate manual transcriptions, manual errors. We knew the solution needed to enable teams to be one click away from the data at all times while providing version control and auditability into both the raw data and the processed results. We knew that what we built needed to scale to handle an enormous variety of disparate, even unpredictable data types going into the future with various instruments. And lastly, we wanted to make sure that we had the ability to easily integrate with other tools and applications. That's on the research side. On the engineering side, we knew that what we built also needed to scale, but more from a DevOps perspective, such that we need to be able to create new connections on the fly very quickly without direct access to the labs. We knew that what we built needed to scale, again, to hundreds of instruments across a dozen of sites. And we wanted to make sure that what we deployed was deployable through IAC, that's infrastructure as code, such that it was these reusable code snippets to create connections with new devices, not any manual ham jamming. And then lastly, we wanted to retain fine-grained access control, such that users could be declared globally, by site, by team, anywhere from these very broad scale to very fine-grained user access controls. So a lot of requirements that meant that we need to be thoughtful on the approach. And I would say that like any good solution, we arrived on the final design through a couple rounds of iteration. But nevertheless, the technology choice that we determined for the movement of data into AWS was DataSync. So approach here for version 1 of the implementation is that we leverage DataSync agents hosted on-prem. These are VMs at each of our sites deployed on our local ESXi clusters. And on these agents, we're capable of defining tasks that map one-to-one with instrument folders that we want to transfer from, each of which has an SMB share over the network. So source location or SMB shares, one per instrument. Target location is S3. And with these tasks running on these distributed agents, we can start to move the data into AWS where we can store it, structure it, archive it, but also just better organize it and start to make sense of it before putting it into the hands of our end users. So that leads us to the right-hand side of the diagram, where we use what I'd say is AWS recommended approach for data lake architecture, but with a resilient spin on it, such that we use a 3-tier bucket strategy where we can land the data and then take it through a maturity curve, going both left to right and top to bottom, where we can organize the data very specifically by prefix, follow very precise naming conventions, while also performing any transformations that clean it up and curate it or partition it to make it more queryable via a query engine, so something like Athena. So a lot of thought going into the organization of the data and the ingestion mechanism, but like I said, it took a couple of tries, so a couple pitfalls to be aware of. The first, like Jeff said, is that DataSync by default only supports a maximum task execution interval of once per hour per task, meaning you can get really lucky in that you just did an experiment, task is about to run, moves your data immediately. Or you can get really unlucky in the sense that you just did your experiment, task already ran, and now you have to wait for this arbitrary 1-hour marker before data moves again. So ultimately, slows down turnaround time on getting data to scientists, don't want unhappy scientists. The second sort of compounding factor there is that not every instrument generates data at the same rate. So it can happen that the task spins up, LS is on-prem, LS is S3, CISA has nothing to move, spins back down. That only wastes about 4 to 5 minutes per task, but when you consider the fact that you might have dozens of tasks on an agent, what you're essentially doing is creating this badly backlogged queue of data that's not moving because your meaningful task might be waiting for a dozen idle tasks in front of it. So work wasn't done. We basically knew that we needed to include a little bit more engineering effort to make this whole workflow more event-driven. So next iteration, we really wanted to hone in on this concept of smart devices, such that we can monitor in real time changes to the data generated on the instruments and be confident that we would only trigger the tasks at the time when we knew that new data had appeared. So right-hand side and sort of bottom of the diagram is still the same. It's still DataSync tasks per instrument that move data into S3, but it's the logic to trigger the tasks that changed here. And double-clicking on the smart device analogy one more time, the way this new setup works is leveraging AWS IoT, that's Internet of Things, to run greengrass agents that are capable of sweeping the same shares that DataSync is transferring from. So those greengrass agents run edge compute, edge lambdas, which essentially can see the last modified timestamp on the lab devices. And what they do is compare that to a global lookup table in DynamoDB, which contains the last successful DataSync task execution timestamp to basically see if anything's changed. So if the timestamp in Dynamo is newer, we know we're up to date, no new days appeared, nothing happens. But if the timestamp on the instruments is newer, then we know that we have new data. We use that to emit an MQTT topic, which acts as the invocation for DataSync, at which point the task does its normal process. So this solved a lot of problems because it means that not only do we no longer have to wait for that arbitrary 1-hour marker before we move data, but it also eliminates the unnecessary run of tasks that don't have any data to move, which drastically sped up the turnaround time. Now, to stick some numbers to it, what this means is that in the span of just a few months, we were able to create this truly global data ingestion process and get data from over 250 instruments across 10 of our sites, connected and all channeling their data into AWS in just 5 minutes from the time it's generated on-prem. And to touch on the infrastructure as code piece one more time, because it's these reusable code snippets that create connections with new devices, onboarding new instruments is quick for our team, to the point that our current record is actually 77 instruments in a day. That was at our Philadelphia site, where we migrated the entire site in the span of just 2 days. So this solves a lot of problems. It's really the first set of hurdles that I mentioned on the intro slide, in that we now have a way to eliminate manual data transfer and transcription. We can provide that centralized means of data backup. We can get data into the hands of scientists faster to speed up learning cycles. And we can really begin to turn the corner and start enabling more advanced automation. But if you think about it, all this was really just the setup for the next challenge, which was how do we front-end this to users in a sort of intuitive, easy-to-use way? Amazon might revoke my pass for saying it, but the fact of the matter is most scientists are not going to log into the management console to get their S3 data. So we knew that we needed to provide a better front end for users that they can interact with. And for that, we turned to Quilt. For those of you who don't know, Quilt is the name of the company and the product. They don't give me money, but they probably should. But it's a product that provides a search interface into S3. So it's hosted entirely in your AWS environment, and it essentially leverages an OpenSearch cluster to index the bucket contents before providing an ECS-hosted web app where scientists can easily browse to their data. And this, again, was incredibly powerful for us because it meant that we could already leverage the data ingestion process we built with DataSync and IoT, such that when new files landed in S3, they'd immediately appear in Quilt for scientists. But it's this intentionally loosely coupled architecture where the data ingestion mechanism is separate from the user access interface, and really no additional DevOps is required for us beyond simply getting the data into S3. So in that way, Quilt for us is a window into S3 that scientists understand because it leverages the already well-structured, specific organization we've built for each of the instruments with DataSync, where the user knows exactly how to navigate to the data generated by the devices. That's the first screenshot you're seeing here with data laid out by organization, by site, by instrument, with, again, wide range of bioreactors, flow cytometers, digital PCRs, sequencers, such that the user can just click in, see their data. But Quilt also provides a search bar. That's the elastic query strings part of OpenSearch coming into play. So very much like a Google search, users can quite literally search through millions and millions of files in S3 that all get rank sorted by the hits they receive. It could be by the name of the file, it could be by the project, the site, very, very wide range in terms of search options. And when you find what you want, you can visualize it, oftentimes inline within the browser. What we happen to be looking at here is a microscopy image for nuclei stains on a tissue section. But from there, you can download it. There's a button for that up at the top, as well as retrieve it programmatically, because for every file you see here, Quilt auto-generates a code snippet that tells you how to get it with AWS CLI or Odo3 to develop your informatics pipelines around. Now, the second most important feature of S3 that this setup allows us to leverage is S3 data object versioning. Because as long as you have object versioning enabled on your bucket, which is a PSA, turn versioning on your buckets, as long as you have versioning on, Quilt is going to give you a view into every historical version of that file that's ever existed. That's this drop-down with hash ID here in the top left, where every version of that S3 object becomes an immutable link with a point-in-time restore that I can always jump back to. And if you think about it, this is really critical for many data integrity aspects, because mistakes happen. Maybe a lab operator accidentally deletes or overwrites some raw data. DataSync will see that, and it'll copy the new object version, but I'm always going to have this point-in-time restore that I can jump back to. So you could quite literally never, ever accidentally delete any raw data. It's just not going to happen because it's going to become a new object version. So in that sense, this process that we've built is also serving a lot of the SDMS functionality for capturing data changes and archiving data, which we need as a manufacturing company. And then last piece I'll mention are Quilt packages. Simply put, packages act as Git control with pointers to file objects, where users can consolidate both the processed and raw results under a single URL that's also version controlled, also one link accessible. And on top of that, users can also add their own metadata tags and commit messages, which also become searchable. So it really encourages users to annotate their results and describe what changes they're making as they're producing these published data sets, and giving other teams a means to easily find their reports. And I'll give you two tangible examples of how we're using this now. The first is that we're able to provide grouped analysis results that are the output of many of the informatics pipelines we have running. So again, data lands in S3 via the DataSync IoT process we talked about, and then simple event bridge trigger kickstarts our analysis pipelines, which can then publish their process results back into S3 as a package, along with any of the metadata that just describes the configuration parameters that went into the job. So it's this incredibly efficient process for providing reports to our lab teams. And the second use case I'll give you is for linking data sets to ELNs. For those of you who don't know, ELN, Electronic Lab Notebook, it's basically a place for scientists to provide annotations and interpretations of their results. But what they very often lack is any kind of easy association with the raw data. But now that we have all the raw data here in S3 and Quilt, I can just insert a link to that package into our ELN entry instead of uploading hard copies or manually transcribing files. And that link behind the scenes can point to dozens and dozens of files in S3 or even terabytes of data. But it's this incredibly compact link that gives me all the auditability I need for the purpose of IND filings or regulatory reports. So for all these reasons, it was a very intentional choice in partnering with AWS, because their tooling really allowed us to build both a scientist and a developer-centric toolset, which is already scaled to hundreds of instruments, about a petabyte of data, and a very easy-to-use web interface where users can quite literally Google search for any data across the whole company, which has drastically accelerated our R&D and manufacturing capabilities. I know we're short on time, so I'll stop there. I'll turn it back over to Jeff. But first, I would be remiss if I didn't show this last slide, just highlighting some of the key team members, some of whom are here today. So John Rinvernider, engineer that built the IoT process, CJ Stone, Jay Peters, Jiro Koga, and Brian McNabb, my boss.
Okay, so thank you, Adam. Love that story. What I love particularly about that story is the ability to scale. That's not something just built into DataSync, that's AWS in general. And it's so key to companies, particularly who need to scale and move quickly, that ability to scale up their processes through automation, DevOps, things like that. So great story, Adam. Thank you for sharing. So quickly, just want to go through some features that we launched in DataSync over the past year. So the first of these were our detailed data transfer task reports. So I've had a number of customers who have come to me and said, look, I'm doing this migration. My boss wants to make sure that all the data was moved successfully. He's not okay with me just, going through and saying, yeah, this file moved, everything looks good, I did a sampling. He wants a detailed report. And so, that was one of the challenges that this was built to overcome. The other is for customers who need an auditable chain of custody reporting, so showing that the data was successfully moved from the source to the destination using DataSync. And so these detailed task reports captured not just the data and paths, but also metadata information, very detailed metadata information, things like checksums, even S3 object IDs, so that customers can get that very auditable chain of custody, knowing how the data was moved from A to B. And these files that we generate are actually JSON formatted. They get put into a bucket that you specify, and then that enables you to use tools like Glue and Athena to actually do some detailed analysis if you need it, or to generate your own reports. So a lot of our customers have enabled this, and we've seen a lot of success with this particular feature. We also launched a capability called manifests. And the way DataSync works today is that when you start a DataSync task, it scans the source location, scans the destination location, compares them to figure out what data actually needs to be transferred. But we have some customers who have very large data sets, the vast majority of which doesn't change, and they know exactly what did change. So for example, I had a customer based in the UK who had a process that would generate files through automation, about 100 to 200 files a day, and then they would get put into a bucket that had over 1 billion objects in it. Well, there's no reason for DataSync to scan the entire bucket, all 1 billion objects, only to figure out the 100 or 200 that actually changed that day to get moved. And so what the customer did was they automated their process, would take those 100 to 200 files during the day, put them into a manifest file, and then when they were ready to synchronize that data to another location, they would simply pass that manifest to DataSync, and it would process only those files, completely skipping the need to scan that whole bucket to figure out the changes. So a great way to optimize data movement when you know the actual files that you want to move. And I alluded to this one earlier. So back in October, we actually launched a new capability of DataSync called Enhanced Mode tasks. And this, if you're familiar, if you've used DataSync in the past, you're probably aware of some of our upper limits that we have today around the number of files per task, as well as some performance limitations that we can hit in certain use cases. Well, Enhanced Mode is designed to overcome these limits, and it basically enables customers to move data sets with virtually unlimited numbers of files in them at much higher rates of speed than previous DataSync versions. We also provide more enhanced metrics and reporting that are especially useful for customers in migration scenarios. And I'll walk through that here in a little bit. But first, it helps to understand, so we launched Enhanced Mode, the old version of DataSync we're calling Basic Mode. So the way Basic Mode works today is you start with the launching phase where we're launching resources to actually process the data movement. And then we move into a preparing phase. And in that preparing phase, that's where we're doing that scanning. We scan the source and the destination and compare them to figure out what needs to be transferred. That's all done in that phase. And only after that's done, then we move to the transferring phase, start moving the data. And when that's done, then we go back and we verify it. So a very sequential operation. But with Enhanced Mode, in order to be able to overcome those limits of the number of files in a particular task, we needed to change how it operated. So we still have the launching mode, but instead of going sequentially, now the preparing, transferring, and verifying mode all happen in parallel. So at the same time that we're scanning the source and the destination, we're feeding those files as we find them into the transferring queue, and then we feed them when they're immediately done into the verifying queue at the same time that more files are being found, more files are being compared, more files are being transferred. So a much more efficient way of transferring data. We've also increased large file performance. So for customers in especially the media and entertainment industry or life sciences, where they're potentially dealing with files that are hundreds of gigabytes in size or even terabytes in size, DataSync now, with enhanced mode, offers much higher levels of performance. So we now take those large files, chunk them up, send those chunks over the network in parallel, and we've seen performance increases of 8 to 10x faster than basic mode. So great for those verticals where they're dealing with very large files. And finally, we also greatly increase the detail in CloudWatch logs. This has been really helpful for customers who maybe need to debug issues that are going on or just want a quick view of the metadata of what's being transferred, and so what things are looking at both the source and destination. So additional detailed logging. So I just wanted to do, this is a video recording of a quick demo, and I just want to walk through and just kind of show what the console looks like when you're running enhanced mode and kind of talk through that parallel operation. So what I did was I started enhanced mode for, this is a transfer between two S3 buckets, and the source bucket has 200,000 objects in it, and the destination has 20,000 objects. Now those 20,000 objects were part of that original 200,000 data set. So I ran an initial data transfer of just 20,000 objects just to kind of demo something here. So what you can see on the left here, where DataSync is chugging through all those objects of the source bucket. It's counting up as it's finding. And as it's finding, you can see it's starting to prepare files and preparing them for transfer. But it's also showing that some of those are being skipped. So as it's going through and it's finding files at the source, it's also finding those same files already exist at the destination. So it's skipping them, saying, I'm not going to transfer them because they already exist at the destination. I don't need to do that. And then you can see as it's continuing to run, files are being transferred and verified, and all of this is happening in parallel. So you can see at this point, we found all the files at the source. We found those 200,000. And then the prepare continues to count up. And it's continuing to skip files as it finds them. And again, the prepare is still doing the same thing. It finds a file on the source, compares it to the destination. The comparison operation is usually looking at things like timestamps, the size of the file. If needed, we'll look at checksums as well. But you can see that here the prepare phase stops at 180,000 files. So of those 200,000 that were listed at the source, 20,000 of them already existed at the destination. The remaining 180,000 were actually prepared. That means we prepared them to go on to the transfer stage. And so the transferring continues to run. And you can see as we continue to run, our data throughput continues to climb. It's going to max out just around 650 megabytes per second, which is actually about 5 gigabits per second, which is the upper limit of a single enhanced mode task today. And so then once it's done, we've transferred all 180,000 files. We've verified all of them. We show status of success. But really, the importance of this demo was just to see how we're now operating in parallel as opposed to the old basic mode execution of tasks, which were done in a very serialized fashion. OK, so just to wrap up, so a couple of key takeaways. Key use cases for DataSync are migration, archive, replication, and those data movement workflows that Adam referred to with resilience. You can use DataSync to move your data between, so both to and from on-prem storage, other clouds, and AWS storage. You can maximize your usage of your available network bandwidth using multiple tasks. And then enhanced mode tasks, which we just launched, increase your scalability and performance when compared to basic mode tasks. If you want to learn more about DataSync, head to aws.amazon.com/datasync. You can use that QR code there. That'll take you to our website. It's got blogs, demos, lots of links to lots of different resources to learn more about DataSync. We've also got some additional sessions today if you're interested in learning more. We've got a Chalk Talk at 3 p.m. over at Caesars Forum, and then another Chalk Talk here in the MGM Grand at 4 p.m., which is generally about storage, but we'll talk about DataSync as well. And then finally, if you're interested in learning more about AWS storage, you can check out some of the links there as well. So I just want to say thank you to all of you for being here, and thank you to Adam for joining us from Resilience. If you've got any questions, we'll be off stage and we can take them over here. Thank you so much.